Right, I welcome you to this discussion. This is the set of additional practice questions that I gave you. You looked at the first of these three questions in your previous tutorial, and in this particular tutorial, in this particular video, I'm going to discuss question 2. I will not necessarily discuss every other question, but only the critical parts to help you then understand what you should be doing, right? Now, as part of the explanation, I propose to do the following. Let me insert some bullet points. Sorry for the noise outside. We have to make peace with the noise of these renovations and other things going on. Now, according to the monetarist tradition, based on the quantity theory of money, inflation is every time and everywhere a monetary phenomenon. Now, you would have done a quantity theory of money in Economics 1 or 2. And certainly in Economics 202, you might have discussed it as well. In 102, when you were looking at inflation, that's where you would have discussed it. And you defined inflation as too much money chasing too few goods as just one of the definitions. Now, the quantity theory of money itself comes from the equation of exchange, which is written as money supply times the velocity of money, that is the rate at which money changes hands, is equal to the price level times, initially it was volume of transactions, but now it has been changed to the quantity of output. So as you can see, price times quantity gives us our nominal GDP here. That's the nominal level of output in the economy. And this is your money supply by the rate at which money changes hands. Now, the idea here is that we are saying this P here, the price level, is determined by the behavior of M. So we have to rearrange this relationship in such a way that we now have P is equal to MV over Q. Now, the problem is this V here is something that is much difficult to understand, to estimate, as it were, but the general assumption that is usually made is that let's assume that it's relatively stable so that we can regard it as a constant. So if we do that, then we can rewrite this as some constant K by M over Q. Okay, now M is nominal money balances, is your nominal money supply, whereas Q is the physical quantity of output. So here this ratio is saying for each unit of output, how many units of nominal money do we have? So if this ratio is bigger than 1, it actually means that we have too much money chasing too few goods. That's what they are talking about, okay? So then this implies that we can then state this relationship in an econometric sense. Let's do that where we should be doing it here. So let's state the equation. The equation now is going to be P is equal to some beta 0, which is your intercept, plus beta or B1 which is your slope coefficient. Since K is assumed to be stable, which may be a very restrictive assumption, it can take any value, and we can assume that it takes the value of 1. It's just a scaling factor, so it doesn't change anything if we assume that it's 1. So then this is multiplied by your M over Q, okay? And you add to this the error term, okay? All these are subscripted with a T because this is time series data. So that's the model you would have stated. What are your expectations? Of course, from the very statement we have up there, it's clear that there is a positive relationship, okay? So your B1 is expected to be greater than 0. It should be small b. Your B1 should be greater than 0 because as your man supply to quantity increases, so will the inflation level. Since you're saying too much money will be chasing too few goods, then you are required to estimate this very model you have stated here. So what we need is to go to our data. Let's create our P. Now remember that this is stated in percentage form because you said your nominal over your real times 100. Okay, that's how you got this. So in fact, in base here, the price level is 1. So let's try to say then this over 100, and then we can just drag to the end, and let's have our M over Q. Okay, let's try to express it that way. Now the challenge that we have is that they are measured in different scales, so we need to transform either these to thousands or these to millions. So what we can do is we also want to express this thing M as a percentage of Q, so we want it to be in percentage form. Okay, so what we're going to do is to say, let's convert our man supply to millions, which means we must divide it by 1,000 here to transform it to millions. Then we divide that by our real GDP. Let me just supply another bracket at the beginning. Right. So we multiply that by 100. And we drag. So that's what we have. So what you can see is that man supply in 2016 was about just 31% of the GDP. So you didn't have too much money chasing too few goods. But as you move into 2019, notice into 2019 Q2, you now have more nominal man supply relative to GDP, and so the percentage is now much larger, and of course this is testified to by the return of high levels of inflation in Zimbabwe. So if you were, as part of, which is good practice when you are doing modeling, you can just sketch the graph to have a sense of how these variables are related to each other. So let's try to do that. Now, because one is measured in percentage form, another one is just an index, not in percentage form. They should not share the same axis. So I'm going to have a secondary axis for my inflation, for my price level, that is the CPI. What you can observe is that they are moving together actually. As your man supply moves, increase at a faster rate here, not also that your prices are doing the same. And what starts to rise much faster is demand supply before inflation does. So inflation responds with a lag, which would seem to confirm monetarist argument that it is too much money chasing too few goods that is behind the inflation scourge. Right, so let's now estimate our regression, data analysis. We want a regression here. Okay, let's pick our dependent variable, which is P. Let's pick our X variable, which is this. Labels. Okay, this is the output we get. Let's just put those p values into percentage form, so you can see that this is an extremely significant relationship. Okay, right. So your R squared there is about 0.887. That means about 88.8% of the variations in the price level are actually explained by changes in demand supply, which seems to agree with our theory. Now, so we have estimated. You are to interpret I'll interpret the intercept for you here. I mean the slope coefficient is the most important one, right? First of all, we can see that it conforms to theory. It is positive, and we had said that we expect this slope coefficient to be positive, and indeed we found it to be positive here. But what does this number mean? Bear in mind that your explanatory variable is measured in percentage form. So what is changing there are percentage points. So when you interpret, you should be careful. You can't say a 1% increase in demand supply. It's a 1 percentage point increase. Okay, so then you can say a 1 percentage point increase in the M3 GDP ratio leads to a 0.041 units increase in the price level on average. Remember that your price level here is an index. Okay, so it is a pure number. It is a unitless number. That's why I use the words units there. Right, so we are done. Notice this is very important. If your variable is measured in percentage form, let's say like your GDP, like your interest rates, your inflation rate, other measures that are in percentage form, if they change, they are changing by percentage points. They are not changing by 1%, by 2%, whatever. Okay, having done that, of course the constant you can always interpret it. This is the average level of this is the average price level when the ratio of nominal money to Q is 0%. Okay, that is if, in other words, it's an economy without money at all, then your M there will be 0 over Q. You get a 0, so your average price level will be negative. Okay, it doesn't make much sense, but that's what it means. Then we are required as well to carry out a test of significance. Now, what we're going to do here, and we have to do it at the 1% level of significance, we have to state our null hypothesis. Now, the null hypothesis professes that this slope coefficient is 0. That is, you are saying, no ways, demand supply does not influence price levels. Then your alternative hypothesis says, look, according to theory, we know that demand supply has a positive influence, so we are doing a one-sided test here. This also means that we only have one critical value at the 1% level of significance. So let's state our decision criterion. It is if T ops is greater than T critical, reject H naught, otherwise fail to reject it. Okay, having done that, then we are supposed to find the T critical itself. Okay, the T critical itself, which is made up of our sample size from this data is 13 units. So that's the degrees of freedom are 13, which is your sample size, minus the two coefficients we estimated, the slope coefficient and the intercept. And we are doing that at 0.01. Our alpha is 0.01. It's a one-sided test. What do we get? We come to the tables. My computer is just misbehaving as well. Okay, so the upper row here tells us the probabilities in one area like they show in the graph. The lower part is the sum of the probability in this area and that area. But here we are doing a one-sided test, which means we are only looking at one area, okay? So we want 1% in this area according to what we just stated, and this is 1% here. So we come down until we get to 11 degrees of freedom. This is 11 under 1%. We get 2.718, okay? That's 2.718. That's your critical value. Then we must calculate our T ops. Our T ops is equal to B1, and we are dividing it by its standard error of B1. Of course, the null hypothesis claims that your B1 is 0. So what we are actually doing, if we were to state it in full, we are saying your B1 minus 0, like that. So you are saying minus what the null hypothesis claims over the standard error of the estimated coefficient. And this, of course, means you are talking about 0.0411 divided by 0.0044. And as you can see from what they calculated, you get 9. That is that divided by that, you get that. That's 9.334. 9.334. Now, if you look at this number, the T ops here, and compare it to the critical value there, it is clear because we are dealing with 1%. So in place of 1.725 here, we actually have 2.718. And you got 9 point something, which is even far to the right of the critical value, which means you are in the shaded region. And the shaded region is a region where you reject the null hypothesis. So then what is the story? Since T ops is greater than T critical, reject H naught, and conclude that at the 1% level of significance, changes in the M to GDP ratio have a significant positive influence on the price level. Notice I've put the word positive there because our alternative talks about a positive effect. Okay, essentially that's the idea. You would have done everything that is expected of you. Then the last question is an alternative way of testing the same hypothesis, but here we profess rightly that we don't know everything. These point estimates might be misleading. So we want to construct a 99% confidence interval, and this requires us to have our B1 plus or minus T critical with 11 degrees of freedom and 0.01 is our alpha, and we are multiplying this by the standard error of B1 of B1. Okay, so this means we are talking here about 0.0411 plus or minus 2.718. That's the critical value we already obtained, and we are multiplying that by 0.0044, which is the standard error there. And what do we get? Now let me try to work that out very quickly. So we have 0.0411 minus 2.718 by 0.0044. Answer, we get 0.029 is less than true B1, that is population B1, and this in turn is also less than true 0.0411 plus 2.718 by 0.0044, which is 0.053. Okay, so this is the confidence interval. Now remember that our null hypothesis professed that the true beta is actually 0. Okay, so here we are talking about true beta here, just in case someone misunderstands what I'm doing there. Okay, so the true B1 is 0, that is the population one is equal to 0. So it claims that the true B1 is 0. So what you need to do is to check if 0 lies in between these numbers. If it lies outside that range, then we reject the null hypothesis. As you can see, 0 is outside this range. Now, since true B1 equal to 0 lies outside the 99% confidence interval, we reject H naught and conclude that changes in the M to GDP ratio do influence the price level positively. Okay, essentially that's the idea behind your confidence interval analysis. So I will stop here. I hope this will be very helpful to you.